You trust your eyes, don't you?
Of course.
You trust that when you look at a wall, you're actually seeing the wall. And you definitely trust that when you chug a coffee, you're getting more energy.
It's sort of the foundation of reality, right? We have to assume our senses are giving us the raw data.
But the research we've pulled for today's deep dive, it suggests that trust is, well, it's completely misplaced. We aren't running on some high-end hardware.
No, we're
Yeah.
running on a wet, squishy biological computer that is full of bugs.
Full of bugs, prone to crashing, and packed with legacy code that hasn't been updated in, what, 200,000 years?
That's the perfect way to put it. We think of the brain as this perfect supercomputer.
Yeah.
But if you actually look at the source code,
It's a mess.
it's a glitchy operating system. It's constantly making things up just to keep the user interface, running smoothly.
Exactly. So today, we're going to run a full diagnostic. We are debugging the human brain.
The troubleshooting session.
Yeah. We've got 10 specific glitches, from why we see ghosts to why we jerk awake in bed, and we're going to figure out why our whole system is so unstable.
And just a little warning for everyone listening. Once you see these glitches, you can't really unsee them. You start to notice the frame rate dropping in your own reality.
Okay, I'm ready. Let's start with the power supply. Or maybe
Yeah.
the power management failure. I have to say, the research on caffeine really bummed me out.
I know. It's heartbreaking for coffee lovers.
I always thought of it as fuel. You pour it in, the engine goes faster. But that's not what's happening at all, is it?
Not even close. Caffeine isn't fuel. It doesn't give you energy. It's more like it just hides how tired you are.
Hides it.
Think of it like this. When you're tired, your brain has a low fuel light. Caffeine doesn't add any gas to the tank. It just reaches onto the dashboard and smashes the warning light with a tiny hammer.
That's a horrifying analogy. So what is that light, chemically speaking?
It's a chemical called adenosine.
Adenosine.
Okay. You can think of it as your brain's sleepiness meter. The moment you wake up, it starts building up. And it's looking for these little receptors to park in.
Like a key looking for a lock.
Exactly. And when it parks, it sends a little signal that says, hey, we're getting tired, time to power down.
So the longer I'm awake, the more these parking spots get filled and the sleepier I feel.
Correct. Now here comes caffeine. The caffeine molecule is a fantastic mimic. It looks almost exactly like adenosine.
So it steals the parking spot.
It swoops right in, steals the spot, and just sits there. It blocks the real adenosine from getting in.
It's a doorstop. It jams the lock.
Perfect. It's a doorstop. But, and this is the critical glitch, your brain doesn't stop making adenosine just because you had an espresso.
Oh, no. So the factory's still running.
The factory is running at full tilt, and now you have this huge crowd of real sleepiness molecules building up behind that doorstop waiting to get in.
And that explains the caffeine crash.
That is the crash. When the caffeine finally wears off, when that doorstop dissolves,
The floodgates open.
boom, a whole day's worth of accumulated adenosine rushes in, all at once. You don't just go back to being tired, you get hit with the entire debt instantly. It's a total system crash.
So we're just borrowing energy from our future selves at a really, really bad interest rate.
And the debt collector is very aggressive.
The only way to actually pay it off then is the system reboot. Sleep.
Right.
I used to think of sleep as just passive. You put your laptop in sleep mode, the screen goes dark, but nothing's really happening.
But the reality is that it's this incredibly active maintenance cycle. It's a cleaning crew coming in overnight.
A brainwash.
Literally, we're talking
Yep.
about the glymphatic system. When you get into deep sleep, your actual brain cells, they physically change their shape.
This part just blew my mind. They shrink.
They shrink by about 60%. Imagine a crowded city like New York, where all the buildings suddenly become half as wide.
So the streets between them just open up.
They become massive channels. And that allows cerebrospinal fluid, basically brain water, to rush in and power wash everything. It flushes away all the toxic gunk that builds up while you're awake.
And this isn't just like brain dust. The research mentions beta amyloid proteins.
Which are directly linked to Alzheimer's disease.
Right.
That's the crucial part. If you don't get that deep sleep, the buildings never shrink. The streets stay clogged.
The street sweepers can't get through.
And that toxic waste just sits there night after night after night. You're letting the junk files pile up until the whole system corrupts.
Speaking of the system shutting down, let's talk about that moment right as you're drifting off. We've all had it.
Oh, yeah.
You're cozy, you're almost asleep, and then bam! Your whole body spasms and you feel like you just fell off a cliff.
The hypnic jerk. It's such a violent glitch for such a peaceful moment.
It feels so unnecessary. I'm in a safe bed. Why does my brain think I'm plummeting to my death?
Because your brain is old. We're running on code written for a very, very different world.
Yeah.
The theory is that it's an echo from when our ancestors slept in trees.
Ah, okay. The monkey brain again?
The monkey brain. Think about it. If you're a primate sleeping on a branch 30 feet in the air, what does it mean when your muscles relax completely?
It means you're falling.
You are falling. So as you drift off in your safe, modern bed, your heart rate slows, your muscles go limp, and the ancient, primitive part of your brain misinterprets that as we're falling out of the tree.
And it hits the big red emergency button.
It screams, "Wake up, grab a branch," and sends a huge jolt to your muscles to catch yourself.
It's incredible. It's a completely useless legacy feature that we just can't uninstall.
It's bloatware. And it's not the only piece of ancient code we're stuck with. This connects right to another common glitch: fear of the dark.
See, this one feels so illogical. I'm a grown adult. I know there's nothing in the basement, but if I have to go up the stairs after turning the lights off,
You run.
I run. I can't help it.
But look at the distinction the research makes here. We're not actually afraid of being alone in the dark.
We're afraid that we're not alone.
That's it. And that little distinction is what kept your ancestors alive. For most of human history, the dark was lethal. We can't see, but predators can.
So it's pure natural selection.
Absolutely. Imagine two early humans. One is brave, walks into the woods at night, assumes everything is fine. The other is anxious, assumes every snap of a twig is a saber-toothed tiger.
The brave one gets eaten.
And the anxious one stays by the fire and survives to pass on those paranoid genes. We are the descendants of the scaredy cats.
So that creepy feeling on the stairs, that's a feature, not a bug.
It's a feature called hyperactive agency detection. Your brain is programmed to assume any ambiguous shape or sound is an agent, a predator. It's safer to hallucinate a ghost that isn't there than to ignore a leopard that is.
The software is just still scanning for leopards in my suburban home.
It's oversensitive antivirus software.
Okay, wow. So we've got power issues and old security protocols. Now I want to get to the graphics card. Because after reading this section on vision, I don't think I trust my eyes at all.
Vision is maybe the buggiest system we have. We think we're seeing the world in perfect 4K, but really we're just getting a heavily edited, compressed feed.
Let's start with the hardware debris. Floaters.
Muscae volatantes.
Yeah, those little squiggly worms you see against a blue sky, and when you try to look right at them, they just dart away. I always thought they were dust or something.
Nope, they're not on the outside of your eye. You are literally seeing junk inside your own eyeball.
Ah, this is where it gets gross. It's the jelly, isn't it?
It's the vitreous humor, the clear gel that fills your eyeball. As you get older, the proteins in that gel start to clump together and form little strands.
And I see those strands.
Not quite. You see their shadows. Light comes into your eye and hits the retina at the back. These little clumps are floating in the middle.
And they cast a shadow on a retina?
Exactly. You're seeing the shadows of debris inside your own eye.
Yeah.
So you can never look right at them. They move when your eye moves.
You're trying to look at the lens dirt with the lens itself. Okay, that's weirdly unsettling. But not as weird as the fact that my brain is just inventing colors.
Magenta, the impossible color.
This one is so cool. So if you look at a rainbow,
The visible light spectrum. You've got red on one end, violet on the other. Red, orange, yellow, green, blue, violet.
and magenta or hot pink is nowhere on that line.
It does not exist as a single wavelength of light. It's physically impossible
So why do I see it?
because your brain is throwing an error code. Your eye has 3 color sensors, red, green, and blue.
Hmm.
If it sees red and green, it averages them and you perceive yellow. Simple.
Okay.
But what happens when your eye sees red and blue light at the same time, the two opposite ends of the spectrum, but it sees 0 green in the middle?
So the brain's getting signals from the far left and the far right, but the middle is totally blank.
It breaks the mat. It can't average them because the average would be green and the green cone is screaming, nope, nothing here.
So it panics.
It improvises. It invents a brand new color to bridge that gap. A color that means definitely not green.
And that color is magenta.
It's a total fabrication. It's the brain's placeholder texture for data it can't compute.
We are hallucinating pink. That's just wild. But honestly, it's nothing compared to the next glitch. The blind spot.
The clone scam tool.
This is the one that proves our reality is just a Photoshop edit. We all have a literal hole in our vision. 2 of them, actually.
In each eye, yes. There's a spot on your retina where the optic nerve plugs in, like a cable. There are no light receptors there at all. It's a dead zone.
So we should be walking around with 2 black holes floating in front of our faces all the time.
We should be, but we don't, because the brain is a fantastic liar.
It just fills it in.
It uses a process called filling in. It samples the texture and color from the area around the hole, like a white wall or a brick pattern, and it just copy-pastes that pattern right over the hole.
It's the content-aware fill from Photoshop.
It is exactly that. It guesses what should be there and paints it in real time, so you never notice the hardware is missing a chunk.
That is deeply unsettling. A part of what I'm seeing right now isn't real. It's just an AI-generated patch.
And you can trick that patch.
Yeah.
This brings us to the processing lags, optical illusions.
The ghost illusion. I've done this one. You stare at one of those weird negative color images for 30 seconds.
It's like a face with blue skin and yellow hair.
Yeah. And then you look at a blank wall and you see the face in full normal color. It feels like magic.
But it's just neural fatigue. You're just tiring out your cells.
How does that work?
Your color receptors work in pairs. Red versus green, blue versus yellow. When you stare at a cyan or blue-green image, your blue and green receptors are firing like crazy. After about 30 seconds, they get exhausted.
They run out of juice.
They do. So when you look at a white wall, which is all colors, your tired blue and green receptors can't really fire. But their partners, the red and yellow receptors, are totally fresh.
And they fire like crazy to compensate.
They fire unopposed, and your brain sees the image in its opposite colors. You're seeing the ghost left behind by tired neurons.
And this also applies to motion, the waterfall illusion.
One of the oldest ones ever documented. Stare at a waterfall, all downward motion for a minute. You burn out the specific neurons that detect downward movement.
Then you look at a stationary rock next to it.
And your downward cells are silent, but your upward cells are still firing at their normal resting rate. Your brain interprets that imbalance as upward motion.
And the rocks look like they're melting upward.
Your whole world starts to breathe and warp. It just shows we don't see reality. We see the contrast between signals.
Okay. We've hit power failures, ancient code, fake colors, and blind spots. But we have to end on the ultimate system failure, the one that feels like a glitch in the matrix itself. I hate this feeling so much. You're in a totally new place having a new conversation, and this wave just washes over you. I have been here before. I have done this. It feels psychic.
It feels supernatural.
Yeah.
But the leading neurological theory is that it's just a file system corruption.
A write error.
A simple write error. Normally, your memory works in 2 steps. Step 1, you perceive something right now, and it goes into a short-term buffer. Step 2, later, your brain archives that into long-term memory.
Record now, save later.
Exactly. But with déjà vu, there's a hiccup, a short circuit. For a split second, the brain accidentally writes the present moment directly into long-term memory as it's happening.
Wait. So as I'm experiencing it for the first time, my brain is simultaneously filing it away as an old memory.
Instantly. So your conscious brain does a quick check of the archives and goes, whoa, hang on, I have a record of this moment already.
But the record is only there because you just put it there a millisecond ago.
Precisely. You aren't remembering the past. You are remembering the present. Your brain accidentally put the wrong timestamp on the file, and it's gaslighting you into thinking you're psychic.
That is so much less magical, but so much more fascinating. It's just a laggy hard drive.
A hiccup in the hippocampus, yeah.
So let's just zoom out. We've got send glitches. We crash because of chemical doorstops. We kick ourselves awake because our monkey brain thinks we're falling. We literally invent colors. We Photoshop over holes in our vision, and we get fake memories from filing errors.
It paints a very humbling picture of the human brain, doesn't it? We are not objective observers of the universe.
Yeah.
We are running on very, very buggy code.
And yet somehow, the system works.
It works well enough to keep us alive. That's all evolution really cares about. The brain doesn't need to know if magenta is real. It just needs to help you spot the ripe fruit.
It trades accuracy for speed. And for survival.
Yeah.
That's the big takeaway for me. Our entire reality is just a good enough rendering. And it makes me wonder, if my brain can just make up a color and autofill a blind spot and create a false memory, what else is it just making up?
And that's the truly provocative question.
How much of what you're experiencing right now, this sound, this thought, this feeling of being you, is actually real? And how much is just the software patch your OS downloaded to keep you from crashing?
And if you could find out the answer, would you even want to?
I think I'll just stick to my doorstop juice and hope the system doesn't reboot on me.
Probably for the best.
Thanks for deep diving with us. Watch out for the glitches. We'll see you next time.